Good evening. This session will be starting definite integration. So far we did just a minute. It's not working. In definite integration, we did in those chapters we did integration as reverse process of differentiation without knowing meaning of indefinite integration. Some of you must have studied indefinite integration as the family of curves. That integration constant you put over there, that integration constant as a fixed value, then it will represent a particular solution. But if it doesn't have any fixed value, write plus c only, then it will be general solution. General solution means that changing the value of c will get same curve repeated. I mean its origin is to be changed. But here in definite integration, no integration constant will be there, and we integrate between two given limits. There is a geometrical interpretation of definite integration to find the area bounded by a curve having irregular shape. We can use definite integration, and we can use definite integration to find the sum of infinite series. That also can be done. So now let us do definite integration as the limit of a sum. Then I will tell you the geometrical interpretation of definite integration. Okay? You just consider a function y equal to fx continuous in AB. It means in the interval a to b, it assumes all the values of x belongs to AB, there exists a value of y. Okay. Now imagine this interval is being divided into some finite number of parts initially, each of length h. Then coordinate of this point we can take a plus h, this one a plus 2h, a plus 3h, a plus 4h, and this will be a plus nh. Okay. The functional value at this point is fa. At this point it is f of a plus h, and at this point it is fb or f of a plus nh. Before this point what is there? That is, there is b minus h. And just after a, the interval will be a to a plus h, then a plus 2h, because each of length h. Okay. So what we did there, we divide AB into finite number of parts each of length h. Okay, this only we did so far. Functional value at these points also we found. Now consider this sum, the sum h into fa, h into f of a plus h, h into f of a plus 2h, h into f of a plus n minus 1 into h. Why this sum we are considering, that will definitely explain. And denote this sum, what you did here, you multiplied functional value here by h, functional value here by h, here by h, here by h, this manner, and before that also b minus h, or the same thing can be written as a plus n minus 1 into h, till that the functional value we found, and then multiplied by h. So you must keep this in your mind, that multiplication is done by h with the functional value from starting point to this point. This sum we take S1. Using summation sign, we can write this one as h sigma f of a plus rh r equal to 0 to n minus 1. Isn't it? This sum S1 we got here. You consider another sum that multiply with the end of the interval also. Okay. Also consider the sum S2 equal to h into f of a plus h, f of a plus 2h plus, what do you mean? I am multiplying functional value here with the length of interval, functional value here with the length of interval, like that. Okay. So every time we are multiplying the length of interval with the functional value at the end of the interval. What are the intervals there? The first one a plus h. This is I1, the first interval. I2 is what? A plus h. And the last interval this way. In is what? A plus n minus 1 h, comma a plus nh. Okay. So in the sum, what we did? Functional value starting point to this point we have done, that is S1. S2, what we are doing? H into this end points of every interval we have multiplied. And this also we are writing by using the notation sigma. This is r equal to 1 to n f of a plus rh. This sum we have taken h into sigma r equal to 1 to n f of a plus rh. When length of subdivisions are very small, like say h is tending to 0, so small that the length of subdivisions going to be tending to 0, or number of subdivisions tending to be infinite. Consider this situation. So either you consider h tending to 0, that is, you agree or not? Because length of subdivisions tending to be 0, so number of subdivisions tending to be infinite. And here it is quite obvious that when you consider the last point b equal to a plus nh, then what does this imply? b minus a equal to nh. So n is what? b minus a by h. When h is tending to 0, this n is tending to be infinite, isn't it? So under that condition, when h tending to 0, n is tending to infinity. Why? As n equal to b minus a by h, we write S1 equal to limit h tending to 0, h sigma r equal to 0 to n minus 1, and S2 equal to S1 equal to this and S2 equal to this. In the limiting case, when h is tending to 0, then under this condition S1 is going to be equal to S2. Or you assume that we are making S1 equal to S2 to work over there. Okay? S1, if you make S1 is equal to S2, that is these two limits are equal, then situation demands a proof of it. Why do you apply this? Why are you assuming these two are equal? N is tending to infinity, that's why I am assuming, but the concept is mathematical. But this way, when you say that S1 we are making equal to S2, then these two sums will represent the sum under the condition when length of interval tending to 0. This is definite integration within limits. Integration within limits. The value of these two sums will be equal to a to b fx dx. Definitely I will give you a geometrical proof of it. Why these two will be equal? S1 equal to S2, that when h is tending to 0, length of subdivisions tending to 0, number of subdivisions tending to infinity. Under that condition, we are assuming that S1 equal to S2. But then question arises, why do you assume? Where is the application? Just let me explain. First, know that what we mean definite integration a to b fx dx, then it is actually summation of this series or this series when the function is defined in the interval a to b and the sum of the function multiplied with the length of interval will be given by this thing. There is definitely a formula in deriving it, but why these two are being equal, automatically question arises in our mind. Why? Let me explain that. So I am going to explain geometrical consideration or geometrical interpretation. Geometrical interpretation. Let us consider the curve which is drawn here representing y equal to fx. This one representing y equal to fx. It is any curve. Okay. and this point is A, the extreme points are A and B. If you draw a perpendicular, that is L, it is A comma 0, BM, that is B comma 0. What we did there, we have divided the interval into n number of parts. Then we said n is tending to infinity. Okay. In the first case, when you multiplied H with FA, okay. So this point has coordinate. Just a minute. Let me move it. Let me make the diagram bit bigger for better understanding. This is a perpendicular drawn on this point from the curve. Perpendicular drawn on it from the curve. Okay. Draw perpendicular at the ends also. Okay. These are perpendiculars drawn. Now, you just check here, this length of interval is H, this part is FA, you agree, and this length is F of A plus H, isn't it? Length of this part is what? F of this length, this perpendicular is FA, length of this portion is, it's like this, length of this portion is FB A plus NH. Length of this portion going to be what? F of A plus N minus 1 into H. Clear? This is okay, diagram you understand? Now, you draw a perpendicular from here to here. Okay? This is AM1. This is say A1. Produce it. Draw a perpendicular here also. A1, M2. And similarly, you go on drawing perpendicular here and produce it, draw perpendicular here. Continue this manner. Okay, here also. Now, look at this diagram. This you have taken FA and length is H. What's the area of this inner rectangle? HFA. What's the area of this inner rectangle? Next inner rectangle area? And till this you consider. Okay, till this you consider. What is the length of inner rectangle? H F of A plus N minus 1 into H. Okay. Now, S1, what we have done before, is the sum of these rectangles. You agree or not? What we have considered before, it is sum of these rectangles. this is equal to sum of areas of all inner rectangles, isn't it? This you understood? These inner rectangles sums we found, these areas. I am shading it with the same ink. I think there is no confusion in it. These inner rectangle areas we got. Yeah, this portion. Sum of all these areas we got there here in S1. Am I clear? There is no calculus in it. It's a very simple observation. Even a class 10 student can understand that I found the areas of inner rectangles. Here I am writing that sum S2. But before doing the thing S2, let us write sum of the areas of the outer rectangles. What do you get? Sum of the areas of outer rectangles. That let me write h into f of a plus h, h into f of a plus 2h, and if you agree I will write f of a plus nh. This is S2. Isn't it? Am I clear? Areas of the outer rectangle I am not showing here, but if I do it, then I have to do it with the help of this white ones. White ones representing the areas of outer rectangles, all outer rectangles areas. The golden one, areas of inner rectangle, white ones, area of the outer rectangles. Isn't it? Done? You understand? Clear? Now just consider one thing. When number of subdivisions we are making infinite or length of interval tending to be 0, just consider an arbitrary place on the curve. Here length of subdivisions tending to be infinity or length of subdivisions tending to be 0, number of subdivisions tending to be infinity. See, I have tried to draw inner rectangle and outer rectangle areas here. Can you distinguish? We can distinguish inner and outer rectangle when n is finite. But in this case, we are not able to, we can't distinguish between inner and outer rectangles, isn't it? See, I have tried my level best to show you what is inner and what is outer, but I am not getting. You have taken very small space between two parallel sides, but even that distance between two parallel sides tending to be 0, I mean very, very small. In that case, areas of inner rectangles and areas of outer rectangles has no difference, and that will represent area under the curve. Got it? So this is geometrical meaning. So let me complete this part. So when n is tending to infinity, that is h is tending to 0, limit h tending to 0, h, this is what? H sigma f of a plus rh, r from 1 to n, which you have done before, and this thing is what? This is h sigma r equal to 0 to n minus 1 f of a plus rh. Okay? Clear? Understood? Now that I am summarizing the result now. When n tending to infinity, that is h tending to 0, limit h tending to 0, sigma r equal to 0 to n minus 1, f of a plus rh, which you have taken as s1, will be equal to limit h tending to 0, h sigma r equal to 1 to n, f of a plus rh, which is nothing but s2. Okay? So under this condition, s1 equal to s2, and geometrically we have seen that in this case both s1 and s2 will be equal to a to b fx dx, that is equal to area under the curve between this. With this geometrical meaning we are supposed to do after 2 classes on definite integration, but as you wanted to know the application, where does it come from, the origin of definite integration, that I told you. It was invented to find this sum. It was invented to find the area under plane curve. Integration was invented because of this. That's why I often say that in the world of integration, definite integration came first. To simplify calculations in definite integration, we need indefinite integration. So indefinite integration is not a separate topic. It is the technique, the method of integration which is used for definite integration. Okay? Now I'll show you 2 applications, one by one 2 applications. The third application, to find the area under the bounded curve, I am not going to show you today. Try to understand 2 other applications. How to apply definite integration to find the limit of sum, what is fundamental theorem of integral calculus, and then how to find summation of series by using definite integration. So we will be remembering this, that a to b fx dx is nothing but what? Whatever you like. If you say that, no, I will write sigma r equal to 1 to n f of a plus rh. Someone says that, no, I will write limit h r equal to 0 to n minus 1 f of a plus rh. Okay? They are representing the same thing under the condition that nh equal to b minus a. This condition is there. Why b minus a? That ab is the interval where the function fx is continuous here. We will stop our calculation if you find that the function not continuous over there. We will stop evaluating definite integration, then it will be improper integral. That I will discuss in some other section. Let me apply this concept. I hope all of you have noted down this formula now to evaluate sums. I will show you just 2 examples. and this is not required for board examination. Board has removed this portion, but for entrance exam this plays a very important role to solve JEE like or WBJEE like sums also. Okay, not only JEE Main or advanced. So you should learn it properly. Let us evaluate this thing. 1 to 2, 2x plus 3 dx by using this definition, that a to b fx dx equal to this or this. Let me do it. So for this sum, when you are going to answer, you can see that a1 and b equal to 2. So NH is what? B minus A. This is equal to 1. What is fx here? That also you write. 2x plus, now just reduce the speed little bit. Here fx equal to this. F of a plus RH is f of 1 plus RH. Okay, 1 plus RH, how to find? Fx is this thing, 2 into 1 plus RH plus 3. My voice is being dominated by the fans noise, no? So 5 plus 2 RH. Clear? Understood? We found f of a plus RH for the sake of this part. So this will be what? H tending to 0, H sigma R equal to, I am using this definition, or 1 to n as you like, it doesn't matter. F of, same answer you will get, because H is tending to 0, n is tending to infinity. This will make these two sums same value. So f of a plus RH, we will put it there now. H tending to 0, H sigma so limit H tending to 0, H, put R equal to 1 to n. Five plus 4H, five plus 2NH. How many 5s are there? N brackets. 2H common, 1, 2, 3 up to n. H, alright, 2 getting cancelled, 5 NH, this H also you take inside, clear? So NH is how much? We have written there, no? NH we have written there. NH is 1. You put it there. 5 into 1. Now put H equal to 0. So 5 plus 1, this is equal to 6. Clear? So the value of the integrand is equal to 6 now by using the summation formula. Definitely we are not going to solve all the sums based on this concept, but this you need to know for your JEE sums. Okay, let us do next one, that e to the power x dx. e to the power x dx. You will start the same manner when you are answering it. You write a. Two different types of sums I am solving, so that when you solve JEE sums conceptually you don't get, you be sound conceptually. A 0, B equal to 1, NH equal to B minus A, this is 1. So 0 to 1, another thing you write, fx is what? F of a plus RH will be what? 0 plus RH, A for H. So this thing going to be limit it's all right, understood? So this will be limit. Now you have to evaluate this series, e to the power h to h e to the power nh. What series is this? Geometric series, you know. It's all right, clear? Then what will be your next step? Your next step will be just to use the fact that NH equal to 1 and the standard limit. This one is the standard limit. E to the power h, e to the power nh is there, you write. This is, you know, 1 standard limit 1, then it's coming e minus 1. Answer is e minus 1. But if you say that, am I here to solve sums like this? Definite integration, as I have seen in physics, chemical kinematics, I used to do just integrate upper limit, lower limit, you put, then you got the value. I agree with you. But there was no concept. As teacher told, that's why integrating, putting the final value, initial value. Then what else is there? There are two fundamental theorems of integral calculus that we learn one by one. Fundamental theorem of integral calculus. There are two theorems, or you can write statement 1 or theorem 1, whatever you say. Statement 2 is theorem 2 actually. Statement 2 is theorem 2. I hope you remember the geometrical meaning of definite integration. What does it represent? Area. Area bounded by curve between two given points. Agree? It represents area bounded by the curve between two given points. So, if I take the function y equal to fx, if we take the function y equal to fx, then area bounded by the curve between 2 points A and B, as we have seen, A to B fx dx, isn't it? This area will represent A to B fx dx, where x coordinate of this point is A comma 0, this is B comma 0. Okay. Now, if we take an arbitrary point on the curve, that P, then this point coordinate be x comma 0. Why have I written this? I will be defining a function which is called area function. Okay? Area function is defined as A to x fx dx. This is called area function. A to B fx dx is the total area, but when we go before that, I mean this portion we consider, not the whole area. X may be equal to B also, but then we are getting total area. When you write A to x, it is a function of x. This is called area function. So statement 1 is what? Let A be the area function A to x fx dx. Okay, then derivative of area function A dash x dx will be fx. This is statement 1. For area function, its derivative is equal to the function. That is fx. This has wide application in solving JEE sums. We will state later on this one as Leibniz rule, but right now you know this one area function, and textbook definition of area function is this. Its derivative will be the function itself. Then Ax is the area function. Statement 2. The same condition, fx is defined, continuous, all those things, monotone, whatever you say. If you say continuous, everything is done. Continuous in the interval A to B. We are going to state statement 2. Let it be defined, the function y equal to fx be continuous in the interval A to B. Then take another function phi x. Let phi x be the primitive of fx. What does it mean? That is d dx of phi x is equal to, d dx of phi x equal to, d dx of phi x is what? fx. d dx of phi x equal to fx. Primitive means that derivative of the function will be equal to fx. Then how does it help? That A to B fx dx is equal to phi b minus phi a. Alright, A to B fx dx is equal to phi b minus phi a. Okay. This is fundamental theorem of integral calculus part 2. We will be working on it mainly. A to b fx dx equal to phi b minor. Let us start some application on it. First, I will not show you many application because this thing you have done before. Where you have done it? This thing you have done before because you have found the application. Those who have studied physics, those who have studied chemistry, okay, all the applications you have done. So you integrate, then upper minus lower. I will be showing you just few sums. How to get it by fundamental theorem of integral calculus, that statement 2, that when you integrate fx dx a to b is phi b minus phi a. So you have to find this phi x, and that phi x we can get by ordinary rule of integration. We can do it this way: x log x dx. If you integrate, then phi x will come. Log x first, this minus x square log x by 2 minus half x dx. Okay, so phi x is found out. Now you will be putting there that phi x1, x square log x by 2, and then integrate, put the value of x equal to 4 log 2 by 2 this minus 1 minus, put x equal to 1, this is 0 1/4. So this is going to be log 4 minus 1 plus 1 by 4 minus 3 by 4, something like this. Okay, so you find fx by using the rule of integration, then put upper limit minus lower limit. This is the concept. Go for another one. You do it first, then I will do 0 to pi x square sin x dx. Be habituated with me. Just find the indefinite part integration and then put upper limit minus lower limit. That is the concept. Okay. Done. Now check your calculation with me. I will be doing the indefinite part first. X square sin x dx. You will be taking x square first function. This minus 2x and plus 2 x cos x dx. Again use by parts. 2 into x sin x minus 1 into sin x dx. Here 1, and cos x integration is just sin x, minus sin x integration is cos x. Okay, don't put plus c over there. So you just substitute there, plus then 0 to pi by 2. So if you put pi by 2 here, it will be 0. Sin pi by 2 1 plus 0 again, minus put x equal to 0. Clear? Because cos 0 is 1, so answer is pi minus 1. Okay? Just ordinary integration, then upper limit minus lower limit. Go for this one. 2x tan inverse x dx. Use fundamental theorem of integral calculus to get it. Tan inverse x, you take first function, 2x integration is x square. 2x square by 2 get cancelled, minus derivative of tan inverse x is 1 by 1 plus x square. 2x integration is that x square only dx. Okay? You are doing this part first. 2x. So this you write. Okay. Now go on separating. Minus this by this, plus dx by 1 plus x square, minus x, and this one tan inverse x. Now you go on putting the values. Put x equal to 1 first. 1 square is 1, tan inverse 1 is pi by 4, plus tan inverse 1 again pi by 4, minus, you put x equal to 0. All are zeros only. So answer will be pi by 2 minus 1. Clear? Just put upper limit, that minus lower limit. Okay? So definite integration here, at least by fundamental theorem, what you are doing, that is just ordinary integration, and then put upper limit over there, that minus lower limit. This is the concept. So here, if you do it thoroughly, you can revise whole of indefinite integration, no? So let us do next one. E to 2e 1 by log x minus 1 by log x whole square. How to do it? And then I will show you how to solve summation of series by using definite integration. This one is a bit difficult sum. 1 by log x minus 1 by log x whole square. This we can simplify. If we take the indefinite part, this way 1 by, or you can substitute also, depend. I am just seeing one hope there. If you differentiate maybe of this form, it may get cancelled. So I am taking 1 by log x first into x. 1 by log x is minus 1 by log x whole square into 1 by x into x dx. And this one as it is, dx by log x whole square. So this will be x by log x. These two are getting cancelled. X by log x e to 2e. Put x equal to 2e. Then put x equal to e. E by log of e. Done. Just upper limit minus lower limit. Okay. So you write 2e by log 2e is what? Log e is 1, you know. E by 1. Now take log 2 plus 1 LCM. 2e minus e into. So you just write e minus e log 2 by log 2 plus 1. Okay, understood? Clear? These sums will not solve now. Okay, let us know the second application of that definite integration as limit of sum. If they have asked you to find the summation of this kind of series, how to proceed, or this kind, okay, try to understand summation of series by using definite integration. I just remind you one thing, that when you are doing this, you should remember a to b fx dx we have written as limit h tending to 0 h we did it or not. So this definite integration is actually summation of this series. This series h is tending to 0. There is no where written that n is tending to infinity, but we can make it. How to? Because you know nh equal to b minus a. So what is h over there? B minus a by n, isn't it? Or n equal to b minus a by h. As h tending to 0, this implies what? N tending to infinity. So this will be limit n tending to infinity. Put the value of h here. B minus a by n. Sigma, you write am I correct or not? Check. What I did, it is correct or wrong? Just check. Is this correct? Because I am just replaced h by b minus a by n. When h is tending to 0, n is tending to infinity. Now let a equal to 0 and b equal to 1. So 0 to 1 fx dx is what? One by n f of a is 0 r by n. 1 by n sigma. Clear? Zero to 1 fx dx is this thing, n tending to infinity, 1 by n r equal to 1 to n f of r by n. Okay? Now suppose we have a series of this form. Can't we write it as 0 to 1 fx dx? So what actually doing here? R by n is going to be replaced by x. This is the advantage. If we get an infinite series of this form, its value is 0 to 1 fx dx. Is that clear? Once more, a to b fx dx is this thing. This we are doing in this class, where nh is b minus a by n, or h b minus a by n, n is b minus a by h. As h tending to 0, then n tending to infinity. The whole sum formula I am changing. How I am changing? I have just replaced h by b minus a by n. Isn't it? We have just replaced by b minus a by n. Then a to b fx dx is this thing only. But on this we are making another simplified version of it, so that when we get a given infinite series in a particular form, we can write the answer very fast. This way it is very complicated. This to this, you have to search for b, a, all those things. But once I make a0 and b1, put a equal to 0 here. 0 to 1 fx dx. This is what? a0 and b1, 1 by n, n is tending to infinity. This is 0, r, 1 minus 0 is r into 1. Bas. Isn't it? So 0 to 1 fx dx is limit n tending to infinity, 1 by n, sigma r equal to 1 to n f of r by n. R by n we can replace by x. Let me show you one example. Whenever you get r by n, no, you will be replacing it by x. Just go through this sum. Can we express in this form here? Just check this particular sum. Is there any pattern like that? Probably it will be better visible. That's why I am making this one green. It's okay. Can you see it now? Using definite integral, find the sum of the following series. Can we express it in this form? Let us try. This sum I am writing n tending to infinity. Then what? N tending to infinity, keeping 1 by n outside, because I need a 1 by n over there. Have you seen that? That's why. I need a 1 by n over there. Keep 1 by n outside. 1 to the power k, 2 to the power k, n to the power k divided by n to the power k. Isn't it? So this is nothing but limit n tending to infinity, 1 by n. This you write 1 by n to the power k, 2 by n to the power k. See what is changing over there? That 1, 2, 3, this way up to n. So there it will be limit sigma what? r equal to 1 to n. I hope you have understood up to this time, isn't it? Now what I have suggested, you will be replacing r by n to x. So this integration going to be 0 to 1 what? X to the power k dx. See how funny calculation is this. Whole series, this infinite series, only this definite integration. Can be done many other ways, but definite integration is great to use for this kind of sums. It is x to the power k plus 1 by k plus 1, 0 to 1. So 1 by k plus 1 is the answer. Clear? Understood? This is not working. This is not working. I have to replace or sir. This is not working. Let us go for next one. This is similar question. Let us do this one. Do this one. Before I start, try to get it. This one, number 5, straight. So I am just showing you another one. I need a 1 by n outside. You agree or not? Formula it is there, no? 0 to 1 fx dx is n tending to infinity sigma r equal to 1 to n. You replace r by n by x. We did it. Here I keep 1 by n outside. So this is 1 n square by n square plus 1 square and this is n square by n square. So this thing will be limit 1 by n. See, let me write the second term. Divide by n square. Am I correct? Here also divide numerator denominator by n square. Here also 1 by isn't it? But the first term only 1. Here I got n minus 1 by n. Here 1, 2 up to n minus. Let me write this one as 1 plus 0 by n whole square. And then write, because I told you this may be 0 to n minus 1 or 1 to n, whatever. So there is a hope. If you write r equal to 0 to n minus 1, isn't it? What is this sum? What I told you? You replace r by n by x. Clear? Understood? Such a big summation now reduced to just value of tan inverse x. Okay, so this will be pi by 4 minus 0. Alright, answer is pi by 4. Got the idea? How the whole series is being changed to that form, most convenient form, and then we are integrating. How to proceed with this sum? I'll just show you 2 more sums. Then I hope you'll be able to tackle this kind of sum for JEE sums also straight. This one you write 1 cube by, another thing, 1 by n I need outside. This strategy I told you earlier also. So multiply and divide by that. I hope you have understood. This one, let me write this way. If you have taken 1 by n outside, it will be half only. Then we are writing n cube into n and n4 plus n4. It's matching. Am I correct? This one matching. With 1 by 2n only. N by 2n, half expected. I got half over there. Now what to do? You divide by n to the power 4. Divide inner and rear by n to the power 4. So what do you get? N get cancelled. 1 by n whole cube. 2 by n whole cube. Check any mistake is there in my calculation. Here also by n to the power 4. This way, n by n whole cube by n by n to the power 4 plus 1. You got the pattern. Okay. One way to solve is sum in mathematics to get the pattern. You got the desired pattern. You just write sigma r by n whole cube. Okay. This r is changing to be 1 to n. R by n to be replaced by what? This I told you in so many sums. 0 to 1 x cube by x4 plus 1. Everyone in this world can do this sum. Just make a simple substitution. Or you don't. You just multiply and divide by 4. 1 by 4 log of log 0, log 1 is 0. So answer is this. Isn't it? Idea is clear? Let me do another type which will help you to manipulate any sum, maybe in JEE or wherever. Okay? When there are product of terms given, how to manipulate this infinite series one. Is it okay? You have understood? Let us go for this kind of sum. I am just doing the manipulation. Answer you will write. See, it is given the particular form. It will be what? Pattern is given only. Sigma tan, which part is changing? It is 1, 2, then n. Tan r pi by 4n. R equal to 1 to n. What to write? 0 to 1 tan pi by 4x dx. Everyone can do this. Remember it, tan mx dx, what's the formula? Log of sec mx. This divided by m. M is what? 0 to 1. Answer is 4 by pi log of sec pi by 4. Sec pi by 4 is what? Root 2 log of root 2. So 2 by pi log 2. Clear? Understood? Just go for this kind. This is your last sum. In this sequence, then you will be trying. Okay? This is not a very good form, but you can make it good. How? Just see the pattern here also. This is 1, 2, 3 multiplied all. I am writing the meaning of factorial n. Okay? Then you give all terms a factor of n. Isn't it? Then you will be using this form. A to the power b is together with log thing. So this will be what? Yeah, e to the power b log a. So you write e to the power 1 by n log of and limit is isn't it? What is the advantage here? You write this as 1 by n outside log 1 by n log 2 by n. You know log ab is log a plus log b. See the fun here now. We got the pattern again. This is what? R equal to 1 to n log r by n. Log r by n, what to write? In the power of e, we can write r by n as x. Tell, oh no, we will not write n tending to infinity anymore. We will just write 0 to 1 log x dx. Clear? Now evaluate 0 to 1 log x dx and then find the value. Okay, you will find 0 to 1 log x dx. Although there will be a problem, you must write in the comment box or WhatsApp me what problem you are facing to solve this integral. I am coming with a session on it, which is known as improper integral. I just put forward this question. Can you solve it? Try. I will be discussing with you next session.